It's a pleasure to present Panasas today here in this audience. My name is Merkel. I am responsible for Panasas in Germany, Austria, and Switzerland. Right now I'm on the behalf of Brand Welch. He does usually high-level file system presentations to this audience, but he has a huge family event. So please forgive me if I can't answer deep technical file system questions, but I have also interesting information for you, which I would like to share with you together. So if you have questions, I know Brand very well, so I can pass those questions. Right, and they took me because we have the same haircut, so maybe you don't see here a huge difference. Okay. Yeah, introduction of Panasas, pretty easy. Professor Garth Gibson was asked in the early 90s to develop a parallel file system. He was asked by the government. They had a project list on a parallel file system, and so he did that. He just actually found it, and later on he did a product, and one of the team members of Garth Gibson, who was Peter Bram, he just developed this project at the government. So Lustre came alive, and Panasas came also alive as a product. I took here from the marketing slide out because all American companies has this marketing leadership thing. Yes, of course, we are market leader. So I skipped that one. Please, marketing, forgive me for that. We do have several partners in our channel, which is SGI, Bull, Macra, Go Virtual, E4, Transtech, Cluster Vision, which are bundling our solution into a HPC solution and deliver this our product to customers as well. And we do have also some gentleman agreements like Dell and HP as well, in several cases. So where makes Panasas usually sense? Of course, we do need a HPC cluster environment, and we do need parallel I/O requirements. So, and these parallel I/O requirements are usually found in aerospace, automotive, bioscience, energy, where we have the most customers at the beginning, but we're also increasing also in universities, industrial, government, and finance. Yeah, I want to dive with you into the HPC challenge, because if you can scale up nodes pretty easy in an HPC environment, but the question is also scaling storage, and this is also a challenge usually. HPC cluster methods applied to storage, so you will have to have scale the capacity, the bandwidth, and the cache. Also integrate it into existing infrastructures. So solving and manage this distributed systems needs automation of management and monitoring, and also expansion of this, which should be dynamically. And also the next question is, what does it do in failure prevention and recovery? Because this is, by this amount of data, we are talking about petabytes, and this is growing and growing year by year, and you have to manage all those kind of things. So these are questions you have to answer by yourself, and also we as a vendor. So we usually, HPC requires a parallel storage system. There are NFS, of course. NFS is usually a bottleneck. There are some companies on the market which can do a kind of clustered NFS stuff. So like Blue Arc or Isilon, they will try that, but actually they are not a real HPC NAS environment. So you have to separate the metadata management and the parallel storage passes via this NFS stuff. And this is how we do that. Usually you find here in the HPC environment hundreds of CPUs hitting a couple CPUs of storage, managing the storage here. And NFS is a simple choice because it's well known, but you will face, after a special size on that, cluster size, a ceiling, and it could break. So usually it could be better if you have a kind of weapon balance on the other side of storage, which can deliver the I/O and the I/O requests by those clusters here. And this usually needs a better file system than NFS can provide at the moment. Yes, this is the architecture. Most parallel file systems, all parallel file systems are using this architecture. We're separating here the metadata management from the parallel data passes to the objects, and this is how Panasas it runs it as well. Lustre, GPFS, Fraunhofer does it as the same. And yeah, actually the metadata management is only causing 10% time from the data management. So 90% is a direct parallel management of the storage components. So this is an interesting number. And this is, to scale up this one, you have to have an object-based disk file system on that kind of thing, because block-based RAID systems are facing here issues regarding by reader heads. You have to collect those blocks together, and this is you get issues regarding performance and throughput and scalability, but also in cases of reconstruction. On object-based disks, you have more intelligence into the system, so it tells you exactly where the object creates, the deletes, the writes, and also the it's internal and gives you more performance during rebuild, reconstruction timeframes, and also it scales up much more better and linear. We implement that file system approach, this object-based file system approach, into hardware. This is one of our hardware pictures. So we have a metadata manager, like we call it director blades. Right here, there's the director blades. They have a pretty strong CPU, which orchestras the system capacities and the metadata services. So we have lots of CPUs. There's a CPU on the director blade, and we have also a CPU sitting on a storage blade. The storage blade has a FreeBSD on it and managed 2 disks. And these disks are in a cluster combined together. And so you have a chassis which is 4 U highs, and it's 60 terabytes raw in 11 blades. So we have a lot of cache here as well. In the backplane, we run dual 10 gig E, so it's active or active passive. It's depending on our product, and we can also deliver InfiniBand router options for connectivity into the IP cluster. Yeah, and this thing is scaling up pretty high. So we will deliver pretty soon in this year, coming up in June, the 4 terabyte disks into the system. So you can have in a single rack about 800 terabytes, and you get out of this storage 15 gigabytes a second, which is tremendous high. And you can scale up this to several petabytes in one single file system. So engineering hated me for that, because I took a screwdriver, actually only for you guys, to see what's inside, and I couldn't manage it to put it back, so they had to do that. But the picture is interesting because I want to show the system a little bit more, the technology which is behind that. So we have those director plates which are, have a Nehalem processor, a little disk, but it's not storing the disk, it's just doing the metadata management, and the metadata will be stored on the storage plates. Storage plates have 2 disks, so we can change that here as well. And the future products will have also SSDs on the storage plate as well, to perform more throughput and make more file creates. We do have also a battery, which is interesting to have, because we have about 90 gigabytes cache in the system. So you don't want to have the case that if something happens, that all the data will be lost. So this battery takes care about a graceful shutdown, so you will never lose any data. Next, so this is the hardware piece behind that. How we run the system, the objects, so we are taking the file attributes and we collecting them into objects which are 64Ks, and we stripe it then all over the storage plates and distributing it over the storage plates in parallel. How does it look like in a minimum requirement? So we have to have, for automatic failover, at least 3 director blades and a couple of storage plates. The storage, the cluster will ask the file request, and the director blades are showing up the object maps and the capabilities, and gives then the storage plates in parallel with parallel passes available. So, and this is a number of where we can guarantee it's 1.5 gigabyte per shelf. So we can deliver 1.5 gigabyte per shelf, and this is scaling linear. So we can guarantee that number. As a side dish, you get NFS and CIFS, which is about per director blade 300 megabytes a second. And this is also interesting. The director blade's taking care about that, and also they're doing reconstruction. I have also some numbers on that. How we do RAID things, we have not the classical standard block-based RAID stuff. We have a declustered RAID, and the system is taking care automatically about RAID management. You don't have to think about how to develop loons in RAID 6 or RAID 5 levels. The system does it for you. You don't have to think about that. We have to maybe to do some fine-tuning on that, that you get the most performance out of it, but this is all you need to do. And that's interesting on that kind of case, because the system makes for small files RAID 1, and for larger files, RAID 5 automatically. We are asked many times about RAID 6, and yes, of course, we will have some RAID 6 plus option this year. This will come out this year, so this will be available as well. So, and we don't have any bottlenecks regarding reconstructions, because we are not using hot spares. We have a kind of, distributed spare space over the blades, which we have open for reconstruction. So, and if you're adding more director blades into these things, we can run those reconstruction things in parallel, which are much more faster compared to other solutions. This is an overview how we run the direct flow, the parallel access. We call it DIRECTFLOW, which is our parallel file system called PanFS. So we can do already here, you have just to install an RPM. We are supporting any kind of Linux flavors, Ubuntu, Debian, all Linux flavors can be made. This is for free, so we are giving out these RPMs for free. So we are developing that, and you have no real hard work about that, because we take care about that one. And then you have parallel access to the storage blades and can grow the cluster. NFS, we are supporting at the moment NFS 3. 4.1 is on the roadmap. PNFS, we are working as a member into this development group, so there is some light in the tunnel, but it will come out next year. So it's this what we are, all vendors are saying since 6 years now, but I think I think we can say 2014 we will have some real productive systems running here. And of course, CIFS, yeah, we support that as well. Yeah, diving into the management console, we have a management console, which is a command line interface. So you guys usually start with that one. Later on, you use the GUI because it's really easy to use. If you set that up on the system, you will switch over it because you don't need to use it very often. It's driven, it's self-explaining, and it's pretty easy to use. So you guys can work that in a few hours and run the system pretty easy. So this is the system management console, which gives you lots of information. You can do lots of activities. You can define snapshots, quotas. You have SNMP and email notifications. So this can be bundled also with our support, and they take care. And if some hardware breaks, it sends it automatically out, and you have it next day available and can do. You can do the replacement by your own because it's pretty easy. Yeah, some informations into the deep things. So in the case something happens, and this happens, disks are getting failure. So if you have a failure like that, you just need to take it out. An interesting thing is we have no bottleneck during reconstruction. If you take it out, you don't have any impact on I/O performance. And the system is doing in the background this load balancing of the objects and the recoverage also of the director blades. And you don't have to think about that, and you have no impact about your applications or things like that. This is an illustrated reconstruction. So we have our file objects on the system, and in the case something happens, we just need to reconstruct those objects. The spare space we don't need to reconstruct, and so we are really much more faster. Secondly, we are also stealing some XOR capabilities of the cluster Linux nodes. So this is also improving the performance of the reconstruction. And as you add more director blades into your cluster, your reconstruction is much more faster than usual. If you take now 3 terabyte disks, this can take a long day. And in our case, we can handle that pretty fast. So yeah, there is no single disk or hotspot or bottleneck for I/O performances. And I do have 5 minutes now. I have to hurry up. So it's fast. These are the numbers. So if you have 3 director blades, it's 16 hours. But you have to compare this. We have 2 times 3 terabyte disks inside. And this is an interesting number. You should keep in mind because you run all those RAID stuff, and you will face this reconstruction times. How much space will be available for me? 3 blades? Yeah. There is no space. It's director blades. So that it means you have at least 3 shelves minimum. So that's 120, 180 terabytes disks usage. But if you want storage blade.